kind of start with geometry and kind of as a motivating reason to look at exponents. Now we're going to back away from the geometry, look at some exponent rules, and then come back to geometry at the end. But we're already seeing, some ideas like how do you square 4 inches, and here you've got this idea of adding like terms, and those are both things that we're going to follow up on. All right, so come down to this giant table. Who's learned exponent rules before? Do you remember anything about how exponents behave? Vaguely, yes. Okay. We'll have to build on that. Let me do the first row of this with you to kind of show you what I want you to do, then I'll let you work on this with your groups. If I take an expression like 5 cubed times 5 to the 4th, how would you write that out without exponents? How many 5s is that really suggesting is what
7.
I want you to think? Okay, so 5 cubed is 3 factors of 5. 5 to the 4th is another 4 factors of 5. And then I can just literally count that I've got 7 of them and write that as 5 to the 7. And eventually we want to be able to go from this expression directly to the 5 to the 7th without writing out all the 5s. It's just nice to do it as we get started. So what's the conjecture? How do we think it's going to work when you're multiplying? Yeah, when you're multiplying with the same base, the exponents are going to be added. Okay, and that's what I want you to write over here. So when you multiply with the same base, add the exponents. And eventually, once we have a whole bunch of these exponent rules and you start to get them confused, go back to something like this. If you're looking at an expression like 5 cubed times 5 to the 4th and you can't remember what to do with the exponents, write out all the 5s and jog your memory on that. Okay? See if you can do the rest of that table with your group. So that same kind of idea. Start with this expression, write it out, condense it again.
Well, in PEMDAS, you would use the parentheses first, so it could just be 15 times 15. But is 15 times 15 the same as 3 times 3 times 5 times 5?
I want you to see that. So is that what you were going to go with?
15 times 15 is 225, 3 times 3
Well, I was just going to say
times
if
5
that
times
square
5
means there's 2 of those.
25. Yeah, that's the same. So it really doesn't matter. You could do
So just write out
either way.
literally what does it mean to square
So
something.
15 times 15, or 3 times 3 times 5 times 5, which could be 3, 2 times 5, 2, 4, 15 times with an exponent of 2.
Guys, don't do them all in isolation. I think every one of you is on a different row. If you have B, talk to her about what you have for B so you guys are all in the same place that way.
For B, you have to distribute the exponent inside of the parentheses. So you get 3 squared times 5 squared.
And then how would you condense it in a different way than what you started with?
Whenever you have the exponent on the outside of a parentheses that says like this one 3 times 5, whenever there's an exponent on the outside, you have to distribute it into the 5 and the 3, so it turns into 3 squared.
What happens to the fraction raised to an exponent? The top
Yeah, and then the
distribution
exponent distributes from the outside
I
of
can
the
write it as 2
parentheses and the
squared
parentheses.
That's literally what it means to square it, but then I can rewrite it and say 2 squared over 3 squared. Wait, she's talking, yeah. Yeah, we're going to talk about what you're about to say. Don't tell, I mean, this is true.
Whenever I'm on my math lab, I get a fraction question or 2.
Well,
I never pull out my calculator either, so it's just like, no, not even gonna touch it. Just like not going.
Yeah, that would be 6, 7. Because if you're doing exponent within the parentheses, then you're multiplying that exponent by the other exponent. So instead of adding the two exponents, so that would be 6
Which is just gonna send you right back to
5
this.
sevens.
So instead, let's look at it as 2 squares. And so this is a good start, because we put a 2 on the denominator as well, so you got a 2. Yeah, like that. Yeah.
Well, I'm double checking right now.
You don't have to do anything with the 7. Take the exponent and multiply it by the exponent.
No, I don't think I will actually.
Yeah, because you can write it out one at a time, right? You write out 2 instead of 2. Yeah.
But yes, it would be 6 sevens, not 5
Make a
sevens.
conjecture from that, that's perfect. Great. I think it says somewhere on there that you don't need your calculator. What? Because actually, that's not gonna help. You'll get too busy crunching numbers and you won't see the pattern.
It does work, right?
Oh, we're checking the conjecture with the calculator?
Yes.
Okay, that I like, okay. That's good.
7 to the 6.
Fraction one, you guys just put it like
That's looking good so
2
far.
divided by 3 times 3.
Hey, I have a question.
Well, the exponent would be 2/3 times 2/3. But to rewrite it,
One of my
you could do
that it was you. Okay. Well, I have this essay for English
over
lessons today.
3
I
with an
have work
exponent.
and I was gonna see if you guys would like read it and see
They both
how
have
it's
the
Paper yet, right?
Yeah. It's it'll be 3 pages, but I only have a page and a half right now.
I didn't have it, except I've got another class immediately
Oh,
after
it's on my
this.
laptop, so I don't.
Yeah, you know what, if you can call me sooner, I would. Yeah, I got back classes today.
Well, I'll probably just not bother my
Yeah, I mean, it's always good to get another set of eyes on it, any, you know, even if it's a peer, they'll catch something that you didn't catch.
But it's not, because the exponent,
Too
I
bad.
guess,
Let's sit back and think about your English
I
grammar.
can see some.
or we can just go in
You're
the
gonna have,
opposite
yeah, you're
direction.
gonna have to keep Googling, if you've got that all beautifully done, you need to.
But we have to see, because one's 5 and one's
It's
2.
the same as the other
And then the
one.
other one, they were both 2. And so,
Yeah, it's just 2
would it be 11
because the
and
inside and then for D, instead of adding
Right, but if we were gonna put one on the outside of the parentheses, we could take 2 and 2, so would that be 11 with the parentheses 3 over 11? And then have a 2 with it?
Sorry.
Or it would be,
and then yeah, because you multiply it together instead of adding them across like you
I mean, I don't know if that will work.
because there's a set of parentheses and 2 exponents right next to each other on the inside
I
and
just have
outside.
one more.
You have to multiply.
That's what I did. It's probably wrong though, because it's a completely different question, so it's probably.
It's just separate inside. And then E, because it's division, you just subtract the exponents, so you get 11 to the third.
Yeah.
Can you do it like 3 times 3 times
Are you allowed to rearrange is what you're asking?
Super easy.
Is that what you mean? What allows you to do this?
Multiplication, the rule of multiplication, you can do it in any order. I don't know how to work it.
And that's good for now, we'll put a name on that.
Multiplication and addition, you can put in any order and you come up with the same answer. Subtraction, division, have to be.
Well, it would be 11.
Yeah, I think you just beautifully summed up, 10